Hey everybody, in this video we're going to continue our study of lines. So we're going to talk about parallel and perpendicular lines. So parallel lines, here's an example, are lines that never intersect. So they never touch, they never cross like this one's cross. So they're called parallel. And one of the things that is nice about parallel lines is that they have the same slope. So if we follow this one, for the slope, the red one. So there's a point, looks like the point 0.01, and if I try to go to the next crisscross, so it'll be up 2 and over 1, and then I can continue up 2 and over 1, up 2 over 1. So it looks like the slope is 2 over 1, which is 2. And if you look at the blue line, so where's another point? Here's a point. I'm trying to find the corners on my graph paper. So then I go over 1, up 2. So it looks like up 2 and over 1 again. So let's see, up 2, over 1. Yes, up 2 and over 1. So the slope here is also 2 over 1, which is 2. So the slope, remember, is the rate at which the line is changing, increasing or decreasing. So the slopes are the same. So they change at the exact same rate, which is why they never meet. So one of the things that we can say about parallel lines is that parallel lines have the same slope. Parallel lines have the same slope. So if this is the slope of this line is m1 and the slope of this line is m2. If we didn't know the slopes, right, what I can say is m1 equals m2. And so now let's look at what's going on here. These ones do intersect, and the nice thing about these ones is that they are perpendicular. Perpendicular means that they intersect at a 90-degree angle. They form a right angle when they meet. And so how do their slopes relate? So let's look at the red line again. It's the same line that I drew there. So this is the slope. This one is up 2 and over 1. So the slope here is 2. The blue line is different though. So let's find a crosshair. So let's do this one. And what does this look like? So it looks like it's up 1 and to the other side 2. So to the left 2. So up 1 and to the left 2. Or you can think of it as down 1 and to the right 2, down 1 and to the right 2. So the slope looks like, so we're going down 1, so -1 and to the right 2. So the slope is -1/2. Or the other way, right, I did it as up 1 and to the left 2. So that would mean the slope is up 1, so positive, but to the left 2, so -2. Notice that either way, we get that the slope is -1/2. So what is the relationship between the slopes? The slope of the red line is 2, and the slope of the blue line is -1/2, and they meet at a right angle. So perpendicular lines, when this happens, we say the slopes are negative reciprocals of one another, right? 1/2 is the reciprocal of 2, right? The flip of 2, you can think of 2 as 2 over 1. So it's the reciprocal, and it's the opposite. So perpendicular lines have slopes that are negative reciprocal of one another. So I'm going to write it with the m1 part. So if the red line has slope m1 and the blue line has slope m2, then one of the things we can say is that m2 is the opposite reciprocal of m1. And so that's what makes parallel lines. Perpendicular lines. Other lines intersect. So this one's intersect as well. But these ones, they're not parallel because they meet. And so the red line is still the same line. So the slope here is 2. And we can just verify. Here's a point on the crosshair on the corner, up 2 and over 1, up 2 and over 1. So the slope is 2. What about the blue line? So let's find a point. So there's this one. So I'm going to go 1, 2. I'm trying to find the next corner. So it touches there. So let's go 1, 2, 3. So it's up 3 and to the left 1. So the slope of this one is up 3, so positive, and to the left 1, so -1. So the slope is -3. So these slopes are not related at all. So these lines are neither parallel nor perpendicular. Perpendicular. So lines, if they intersect, they can just intersect at a regular angle. If they intersect at a right angle, that's when we say they are perpendicular. If they don't intersect at all, then the lines are parallel. And so how can we use this information to find equations of lines? Let's do an example. So this one says, find an equation of the line containing the point 2, -1 that is perpendicular to this other line, 2x plus 5y equals -8. Okay, so what is going on here? So let's put in the line. So we have the line 2x plus 5y equals -8. So I drew it over here for you. And it has to contain the point 2, -1. So where's the point 2, -1? So I'm going to go x is 2. So 1, 2, -1. So this is the point 2, -1. So our line, right, notice that it says find an equation of the line that contains this point. So our line has to go through the point 2, -1. So that's this point. This point is not on that line. So our line that passes through this point has to be perpendicular to the line 2x plus 4 equals -8. So we have some other line here, and this is the line that we want to find the equation of. See if I can move it over here. So I want to make sure that I find the equation of this line, and just bear with me here. And these are supposed to be perpendicular. They make a 90-degree angle when they meet. So this is the line that I want to find the equation. So what's the equation of that line? Remember, to find the equation of a line, what is it that we need? Two things. We need the slope, and we need at least one point. We're in luck because we have the point. We have the point 2, -1. But we don't have the slope. So, and I don't have a second point on the blue line to find the slope. So we're going to use the fact that the lines are perpendicular to be able to find the slope of our line. And we're going to use what we did over here. Perpendicular lines have slopes that are negative reciprocals of one another. So then I know that my line that I want to find, the slope here, so I'm going to call our line the second line, so it'll be M2. So M2 is going to be the negative reciprocal of M1. So the red line is the line that we're given. So that's going to be M1. So what is the slope of that line? Well, let's see. The line is 2x plus 5y equals -8. So let's put it in slope-intercept form so we can find the slope. So that means solve for y. So I'm going to have subtract 2x from both sides. So we'll have 5y equals -2x minus 8. And then divide both sides by 5. So dividing both sides by 5 means divide everything by 5. So be careful. Sometimes I see people divide this by 5 and just divide the x term by 5. Make sure you divide everything, the whole side, by 5. And so these cancel, and I'm left with y equals -2/5 x minus 8/5. Right, I have to divide everything by 5. I don't really care about the -8/5. We're looking for the slope. The slope here is -2/5. So that's the slope. Well, I guess I shouldn't have used blue. Let's stick with the red. The slope is -2/5. So that's the slope of the line we're given, M1. So what is the slope of the line that we want? The opposite reciprocal of this one. So the line that I want, so my M2 is going to be the opposite. So since this is negative, my slope is going to be positive, and the reciprocal of 2/5. So the reciprocal of 2/5, I just flip the fraction. It will be 5/2. So this is my slope. this is what I'm after. So back to what we need here, the slope and a point. Now we have the slope and we have the point. So let's go back down over here. So now I know that the slope is 5/2 and the point, right, my x1, y1 is, what was it? 2, -1. And now we can either use the point slope form or y-intercept form to find the equation of the line. So I'm going to use the point slope form. So y minus y1 equals mx minus x1 and solve it this way. So it's going to be y minus y1. So this is my y1 and this is my x1. So minus and minus 1 equals the slope, which we found it to be 5/2, the opposite reciprocal of the line that was given to us, x minus the x value of our point, minus 2. And then we solve for y. So minus and minus becomes plus. Distribute the 5/2, so I get 5/2 x. And isn't this nice? 5/2 times a minus 2, which since you're multiplying, the 2's are going to cancel out. So I'm just going to be left with 5. And to get the y all by itself, subtract 1 from both sides. So I'll have y equals, those cancel, 5/2 x minus 6. And that will be the equation of the line. If you're entering your answers or WebAssign, just pay attention to how do they want you to answer the question. Do they want you to put it in slope-intercept form, here y equals mx plus b, or do they want it in standard form? Right, so this will be in slope-intercept form. Which is your y equals mx plus b. Because from here you can get two things. You can get the slope is 5/2 and the y-intercept. Don't just give me the minus 6. What's the y-intercept? You have to give it as a coordinate pair, so it'll be 0, -6. So that's the slope-intercept form, or you can put it in standard form. In standard form means we need to get rid of the fraction and make sure that the x and the y are on the same side. So getting rid of the fraction, I'm going to try to do it somewhat quickly here without showing many steps. So if you want to see how I did it, just send me an email and we can go over it. So multiply both sides by 2. I'm going to have 2y equals 5x minus 12. And then bring the x over to the other side. So -5x plus 2y equals -12. But the a is negative, so multiply everything by a -1. So you'll have 5x minus 2y equals 12. And so this will be the equation of that same line in standard form. So just check on WebAssign. Do they want the answer in slope-intercept form, y equals mx plus b, or in standard form? Okay, and how will this problem change if I had asked for the lines to be parallel? So if it said find an equation of the line containing the same point, 2 and -1, that is parallel to the same line. So our slope, instead of being the negative reciprocal, they would have been the same. So the slope being -2/5, I would have kept it as -2/5 because parallel lines have the same slope. So I hope that this video helps in solving those parallel perpendicular line problems. Email me if you have any questions.